Okay, number 11. It just says for the polynomial function below, we're going to list each of the real zeros and the multiplicity, determine whether the graph crosses or touches the x-axis at each x-intercept, determine the maximum number of turning points on the graph, determine the end behavior, that is, find the power function that the graph of f resembles for large values of x. Okay, so we're going to do all of this one at a time. Here is the function that we're going to be dealing with. So I'm going to write this function down. We'll answer those questions all together, and then we will input the information. So number 11, f of x negative 9, x minus 2, x plus 5 squared. All right, so the first part said list each real zero and its multiplicity. So it's already factored for us. You just take those factors and set them equal to 0. So part A, x minus 2 equals 0, x plus 5 equals 0, add 2, and you get x equals 2, subtract 5, and we get x equals negative 5. Now, this one will be multiplicity 2. I'll say multiple 2 because we have the squared, so that means that's a double root. This is a single root. So those are the zeros. All right, part B, determine whether they cross or touch. All right, so how do we know if they cross or touch? You look at the power or the multiplicity. So odd, let's just say part B, odd multiplicity will cross even multiplicity, it will touch. Okay, so that is the rule. If it is an odd, which this one is a 1, that will cross at x equals 2, because that's at 0. This is an even up here, so this one will just touch at x equals 5, negative 5. So cross, I want to say cross at 2, touch at negative 5. So that's going to be our part B. Cross at 2, touch at negative 5. C wants us to determine the maximum number of turning points. Okay. So turning points we have to figure out are degree minus 1. All right, so how many x's do we have, even though we don't have it all multiplied together? This is degree 1, so that's 1x. This is 2, so 1 plus 2 gives us a degree of 3. So there's 3 x's all together, subtract 1. That gives you 2 turning points. So I'm going to say TP, 2 TP for turning points. And then D, determine the end behavior. Okay, so we have degree 3, all right, which is odd. Okay. So just remember that end behavior we looked at earlier. So odd, positive is up on the right, down on the left, negative, looks like it says add. Odd and negative will go up on the left and down on the right. So we already know it's odd, we just need to figure out which one. All right, so the leading term is going to tell us the positive or the negative. So if we look out front, we have a negative. So because that's negative, our end behavior is going to be like this. And so this is how we write end behavior. So this means as on the x-axis, we'll say as x goes to the left, so we'll say negative infinity. They generally say y value, or f of x, goes to positive infinity. It's going up. So x goes to the left, negative, y is going up. And then as x goes to the right, this direction, to positive infinity, f of x, or your y value, is going down, goes to negative infinity. So this is how you represent in behavior. So this is all the parts in behavior, turning points, where it crosses or touches, and the actual zeros. So we're going to just put all that in now that we have all the parts answered. So A, the zeros are, let me see, it says type, exact answer using radicals, integers. It doesn't say if I'm going to be doing the multiplicity here. So I'm just going to say 2, comma, negative 5. Okay. The multiplicity of the larger zeros is, so the larger zero is 2. So it has a multiplicity of 1. It's only one of those. And then the multiplicity of the smaller zero, the smaller number is negative 5, and there are 2 of those. So the multiplicity is 2 here. All right, now it says the graph blank the x-axis at the larger integer. So does it cross or touch? At the larger integer, which was 2, it crosses. The graph crosses the x-axis at the larger x-intercept. The graph touches, okay, when it's negative 5, because it's even. Okay, even roots touch, odds cross. And then the maximum number of turning points is 2. Okay, it's always your degree minus 1. And then knowing our degree, the end behavior, type the power function that the graph of f resembles. So it resembles, I guess we'll say negative x to the third. So this is based on parent functions. Let me see if they give you a list of those. No, they don't show the textbook. But the power functions are just like x, x squared, x to the third, so forth and so on. So this is the basic power function because we have a third degree, and then because it's negative. That's what the end behavior is going to do, like that. So maybe they just want negative x, because you don't have to have that power up there. Okay. Let's actually see what they want when they say power function. That's a different question than I'm used to. So we got all the other parts. Multiplicity. That's the numbers for their examples. Keep going. Tell you odd, which one is odd, where it crosses, even if it touches. Okay, here's the degree. Tell you the degree of 3, so the turning points, all of that, leading coefficient is negative 3. Degree of 3, so that helps you tell the end behavior. So the power function resembles, so I guess they want the leading coefficient out front. That's what I'm missing. That's what it appears, because theirs is a negative 3. So I just need the coefficient out front. So negative 9x to the third. That's what I'm missing.